We all love our ESP8266 ports. We all love them because of their Wi-Fi connectivity, but one thing was missing, and it is the USB support. It has many peripherals, but no USB. So we cannot just connect an USB cable and make a keyboard or mouse out of them. Or can we? If you take a look at the datasheet of the ESP8266, there are quite a lot of peripherals listed under here, but there is no USB. And I find it a little bit strange because this microcontroller is quite fast, even though it is not supported on the chip. I think it should be able to emulate it at least. First thing I did was soldering ESP12 module to a breakout board. You can of course use ESP12 module without a breakout board, but it makes things easier. And also on this breakout board, I can solder a voltage regulator on it. The reason why I am using a voltage regulator is I want to use the 5V USB channels directly on the ESP, because USB provides 5V, however ESP12 modules works on 3.3V. After your soldering is done, cleaning the board is important. Then I cleaned the entire board with ethanol. Then I removed the 0 ohm resistor from the breakout board to use the voltage regulator. My soldering skills are not that great, however it should work like this I think. And you need a resistor which has a value bigger than 1 kilo ohm. Currently I am using a 2 kilo ohm resistor. You need to solder this one between GPIO pin 4 and 3.3V. And this is one of the pins that we are going to connect the USB cable on. Then I soldered the USB cable to GPIO 4, GPIO 5 and also 5V and ground pins to the breakout board. By the way, if you are using a Node MCU, you don't need any of these steps, but I wanted to have something more compact. This is how you should solder the ESP8266 module to a USB cable. The important thing here is the resistor value. It should be bigger than 1 kilo ohm, and also you should keep the USB cable as short as possible to eliminate the signal interference. This is the final look after the soldering. Only external components that I have soldered are a voltage regulator and one external resistor, and USB cable if you want to count that one as well. Then you need to get the toolchain, and you can install it natively. I am using Ubuntu 16 by the way. To install toolchain natively, you need to install these packages. Don't worry, I will put a link down in the description. And also later Ubuntu versions might need this package as well. And after that you need to make it. But I don't really recommend this method. I recommend building over Docker, because installing the libraries to your system directly sometimes makes things complicated on your system. So instead I recommend using a Docker installation, and not because just it doesn't mess up with your system, but it's really fast. All you need to do is pull the image if you trust the author, otherwise you need to clone the repository and then make it yourself. And that's it, way faster than installing it natively. Then you need to open a terminal and put this code to flash the firmware. And here USB 0 is the port that your ESP is connected to. And this is the location of the downloaded files. It can be different on your system. And after modifying these two values according to your system, then you need to hit enter. And it will compile the code and flash it to your ESP device. And if you want to burn the web image as well, copy the second part of the code and paste it. Also, if your system doesn't have this package installed, you can install it manually, like I am doing it right now. But if it is already installed, you can just skip this part and enter the project location in the terminal by this code. Now you are ready to compile the web interface and flash it to your device. and then your web interface is flashed to the chip. Of course, you can modify the code for your own project as well. All I need to do right now is connect my ESP board with a USB cable that we have soldered. I connect it to the device from my phone over Wi-Fi. From here, if I open a web browser and browse through the IP address of the ESP8266 board, I can use it as a web mouse and keyboard. You can use it as a mouse by touching the green box area. Of course, other mouse are also supported, like left click, right click and middle click as well. And if you want to use it as a keyboard, if you go a little bit down below, in your phone you can type in just like a regular keyboard and it will emulate the keyboard over the USB. I think it opens up new possibilities in our projects. For example, we can use it as it is, as a keyboard and mouse. And we can also build like micro keyboards and mouse for gaming. And with a few tweaks on the code, we can make mouse and keyboards which we can control it from over the internet. All we need to do is connecting a resistor to the board and that's it. I think it's pretty amazing that what we can achieve with these little ESP devices despite being them pretty affordable. And like always, if you like this video, don't forget to give a thumbs up and see you next time.